Today's lecture is about, hang on. Okay. All right. Today's lecture is about the bash command structure. So basically using commands in bash. All right. So you've seen already that when you're using a command line interface, you basically type something into a terminal, you press enter, something happens, right? So when you type in a command can be one of 4 different things. So it can be it can be a command that the shell understands, right? So remember, the shell is the program that interprets what it is you type in to the terminal. So the shell has a small number of commands that it understands directly, right? So for example, cd or pwd, right? Change directory, print the working directory. It can be a program. So you could write a program in C or Java or any other programming language, right? It's somewhere on your file system. If it's accessible to the shell, then a command can be just one of your compiled programs. It could be a script, so an interpreted language like Python or Perl or Bash, which we'll be doing in the course, right? These are all possible examples of commands. There are the things called aliases. So as you'll see today, there's a lot of commands that you type in, and they often have options that you want to use. If there's a particular command with a set of options that you like to use a lot, or if there's a sequence of commands that you like to use a lot, you can create what's called an alias and store that somewhere. So typically you store it in a file that your shell reads when it starts up. And so then you can, and you give it a name of some kind. And so you'll end up with an alias that's really just a shortcut, abbreviation, or a means of avoiding typing a long command sequence. And finally, you can write a function in your shell scripting language, and it's possible for the function to be called directly from the command line. Now, if you want to know what the type of a command is, you can, there's a command called type that actually tells you what the type of a command is. So if we, our terminal. Okay, so ls, right? You remember ls is the command that lists the contents of a directory, right? If I want to know what type of command is ls, on my computer, when I press enter, I get ls is aliased to something else, right? So it turns out that the ls command on my computer happens to be an alias. So it's the third thing on the previous slide, right? It actually tells you what it's alias to. So it says it's actually the command ls -- color equals auto. And that's why I have colored output here. So it turns out ls is actually an alias, but there is in fact an ls program. So if I type \ls, right, this one will run the actual ls program, and you'll see that nothing's colored. Right? So this is just plain old ls, and that happens to live in root user bin in that directory. If I type in type cd, right, now remember cd we know already is a built-in command, is a shell built-in. So that will tell you it's a shell built-in. And then finally, there's this command la that I haven't used yet. But my shell says that la is alias to ls minus capital A. Right? Now, let's see what ls minus capital A does. Oh, well, let's see what la does. So hang on. So here's ls, and here's la. Now notice that LA, so LS lists all this stuff here. LA will list everything that's here, but it will also list the hidden files that are in my directory. Hidden files and hidden directories, right? So anything that begins with a period in Unix or Linux is what's called a hidden file, right? It's hidden only in the sense that when you type ls, you don't normally see it. That's all that means. So you see there's something called bash history, logout, bash rc, and a bunch of these other files, right? So these are typically files or directories that store configuration information. Okay, so for example, bash rc, that's one of the files that bash reads when it starts up. What else is here that's interesting? Anything else here interesting? Nothing here is terribly interesting for our purposes. So if you want to list all the hidden files in your directory as well, you can use LA or ls minus a, right? So ls minus a and LA, they mean the same thing. Well, LA means the same thing as ls minus a, right? That's why it's called an alias. Now, if you want to know, sometimes it's useful to know where the actual command is on your file system, right? So what program or shell script corresponds to the command ls or cd or la, right? So the which command will tell you where the program actually lives on your file system. So if I type in which ls, it says that ls is the program that's in root, user, bin, and ls. So if I list the contents of root, user, bin, you'll see there's a whole bunch of stuff, right? You scroll through it and look, you will eventually find the ls right there, right? So you can actually find out where a particular command happens to be, right? If you type in which cd, now remember cd is a built-in, so it's not going to say anything, right? So it's at what? If it prints nothing, you know that the command either doesn't exist or it's a built-in or alias, right? So if you do which LA, it also prints nothing, right? So LA, because remember LA is an alias for something else. All right, so we've seen ls a lot already, so I think I'm just going to generally skip over this. Oh, I guess we can do this. So it lists information about the current directory by default. So type in ls, it lists the contents of the directory, but it actually does more than that. So let me switch up to the bin directory. Right now, if I type in ls and then give it an argument, right? So if I type in ls, right, it will print out information. It'll say that, oh, the file ls is actually in this directory. Right. So let me see what else is in the directory. There's a whole bunch of stuff, right? So I can ask for information about a particular, or I can list the information about a particular file. So for example, ls minus als. Oh, that doesn't do anything. ls minus hls. Oh, that also doesn't do anything. Oops, alt. How about we do that? Okay, there we go. That's a little more interesting. Okay, so I don't need the a. I just need long. Sorry. Okay, so there's the long listing for ls. Right. So the ls command. I'm asking for information about this file named ls. Right? Minus l. That gives you the long listing, or more information about this file named ls. Right. We'll look at it in a later lecture. We'll look at what all this stuff actually means. Right. For now, that's its file size. So that's how much space on disk ls actually takes. This is the owner of the file. So this file is owned by root. Right. Root is the super user in Linux. So it's the administrator in Linux. September 5, 2019. That is the date. I think it's the date at which the program was created, or I think when it was created. Not created, sorry, when it was last modified. This stuff up here we'll look at in more detail later on. Oh, hey, I've got some commands here, some examples here. Let's follow this. So ls minus sls, that prints out the size, right? Notice that's different than that, right? So it's printing out the size in a different unit. Right? So ls prints out, minus s prints out the size in what are called blocks. Apparently it takes up 140 blocks on my CD. If you want the size in bytes, right? So kilobytes or megabytes or gigabytes, right? You can use ls minus sh. The h is human readable, right? So now it says it uses 140,000, right? Which is approximately equal to that, right? And remember, you always have man, so you can always ask for information about ls to find out what all of these options do. Right? So if I go to minus h, we see that it's human readable, right? With -s, it prints out sizes like 1,234 megabytes, 2 gigabytes, etc. Right. -s, you keep on going through, tells you that it prints the allocated size of the file in blocks. And there's lots of other options. Okay, so shell commands in Linux always have the following structure. Right, it's command, the name of the command, minus options. So these are whatever options you need to pass in the command to affect how the command works. Right, and then whatever arguments the command expects. The options are usually optional. That's why they're called options. Right. Arguments are also sometimes optional. Right. So some commands don't need any arguments. Like ls. Right. Ls on its own prints the contents of the directory. Right. But ls with an argument, say sed, right, will print out information about the file sed. Right? So sometimes both of these things are optional. And you can combine options as well. Right? So if I use ls with minus big A sh1, okay, that's actually using the options big A, S, H, and 1 all at the same time. Right, so let's see what that does. ls minus A, sh1. Right, so that prints everything out in one column. Right, so all the file names get printed out in one column. sh, that's the size in a human readable format. Right, minus A, that prints out all the hidden files if there are any. So let's see if there are any. Oh, this is probably a bad example. There's too many files. There's too much output. Oh, all right. Here we go. Okay, so is there anything? So it turns out there is no. It doesn't look like there's any hidden files here. So you can combine them all. So you can combine. You can pass in many options. If you want to, you can separate them. Right. So you can list each option separately if you like. Right. And finally, there's also what's called the long format options. So usually the long format options begin with a double hyphen. Right. So capital A turns out to be almost all, right? Size is minus S corresponds to minus minus size, and minus H corresponds to minus minus human readable, right? There's no long option for -1. So this is for better readability, right? So when you read that, it becomes pretty clear what options you're passing to ls. But you don't want to have to type that if you don't have to, right? So normally when you're working at the command line interactively, you use the short options. If you're writing a script that lots and lots of people might have to read at some point in time, you can consider using the long options. Right? Normally, for most commands, you have you have the ability to use either a short option or a long option. Okay, so there are lots of options for ls. At some point in time, you have to go through the ls command. You have to go through the man page or search for ls on the internet and find out what the options are available to you. Right. The most commonly used ones are probably here. Right. Minus A and capital A. These are the ones that list all of the hidden files. Right. These two are almost identical. Minus D. So that lists the name of the directory instead of its contents, which is occasionally useful. So if you have a directory that has many directories in it, and you just want to list what's in the directory, you just want to list the directory name and not what's in the subdirectories, you can use -D. Classify, this is actually not that commonly used, I don't think. But let's take a look at it. List ls -f, and I'm just going to do this. All right. So I'm listing all the files that start with S, right? -F, it's going to try to print some symbol or information or do some highlighting on the file name that tells you something about the file. Right? Anything with a star is an executable file, right? But those also show up in green on my on my display. What else? At, that's what's called a link. We'll talk about those later. Stuff in red, those are important. Those are privileged files. So the stuff in red, you need to have super user access to run those, right? If I want to run su or sudo, I have to type in a password for the for a super user, right? For an administrator on this computer, and so on and so forth, right? -H we've seen human readable. -L long format. We'll look at this later on. And -R you can reverse the order, right? So there's oh, you can sort. Right. So often you'll want to sort, you'll list the contents of a file and you want to know what's the most recent file that I modified. Right. So I want to see that at the top. I can sort by time. Right. By default, it sorts by name. You can reverse the sorting order. And there's lots of other, you can also sort by other things. Right. -1, that's one file per line. So instead of a man page, there's also the option help. Not every command supports this option. Okay. So if I type in ls -help, so this doesn't look like the man page. This is typically shorter. The man page is the what serves as the formal documentation for a command. Help is the more user-friendly help. Right. So if your command supports it, you can ask for help on the command. You can also, if you need, so remember that some commands are built in, right? If you want to find the man page for a built-in command, they don't exist. So you have to do man built-ins, or you can ask for help on the command. Okay. So if I do cd --help, that, right? Remember, if you do man cd, you get nothing, right? It says no man entry. It's because cd is a built-in. The long option help is the same as the help command. Right. So it gives you the same, it tells you the same information. Okay, so you've seen man pages before. We don't need to look at this. Well, we can look at this again. So when you look at the man page, I think I told you this before. Anything that shows up in square brackets, these are optional, right? ... means multiple items are allowed. Now, navigating the man page, I haven't shown you how to do this yet. So the man page, when you display a man page, it uses this program called less to display the contents of the man page. Okay, so let's, okay, so I'm going to go back to my home directory, list a bunch of files. Okay, is there anything interesting here? I don't think I have a really long file here, which is kind of too bad. So less will list the contents of a file. Right? So when I list the contents of the file unsorted, right, I get the lines that are in the file. Right? But less is actually a more powerful program than that. So if I do man ls, okay, so what man ls does is that it takes the man page for the ls program and then sends it to a program called less. Right? And you can see that less, you get this little line down here. Right, so this is an interactive program, and I can move in throughout the file that describes the ls command. Right, so I can move forward one line, right, by using Enter or E or Control E, J or Control N. Why there are so many options, I don't know. Right, but let me press E once, right, and you see it goes forward one line, right, and again and again. If I want to go backwards, I can use Y, so I can go backwards in the file. Right. If I want to go forward a whole page, it's space or F. Right. So if I press F, I go forward an entire page. Right. I can back up with B. Right. So back up again. I'm at the beginning. So go forward again. I can back up one line. Right. With Y. Right. And then you've got some other options here. These ones do the same thing as E, Y, F, and B, except they also let you set how many windows to go backwards or forwards. So you can quickly scroll through a man page just by repeatedly pressing the space bar. Notice that the man page for ls is quite long. A lot of people find Googling or searching for the man page easier, right? So if you just type in man ls into a web browser, you can get the HTML version of the man page, right? So you can look at it all on a separate browser instead of using the terminal. If you do man calsay, you can find out what the calsay program does. Okay, so man calsay, right? And you can see that you can change, if you actually read the man page, you can see that you can change how the eyes look like. You can change what animal is used or what image is used for the cow. You can change how the tongue looks like and a bunch of other things. Now, when you're working with commands, right? So you're working on the command line. Often you want to go backwards. You want to repeat a command that you typed in, right? It turns out a lot of the time you want to repeat the command that you just typed in. So your shell has what's called a history. So bash and the Z shell, if you're on Mac, it remembers what commands you've typed in. And so to get the list of commands that you typed in, you use the history command. So I type in history, and you can see here it spits back all of the commands that I've typed in. There is a limit to the history. So you can see here it doesn't print them all out, right? So it only goes back to 1068 on my computer. What's the most recent one? Sorry. 2000. So it looks like my shell is set up to remember the last 1000 commands that I typed in. And notice that each command has a number. Right? If I want to repeat a command, I can use exclamation mark, right? And then the number. So if I want to repeat the man page for calsay, I can do exclamation mark 2066, enter, and there you go. Right? If I wanted to repeat command, I don't know, 2053, again, it's just exclamation mark 2053, and there you go. The up and down arrows for bash and for most versions of bash and the Z shell will manually scroll through your history. So if I press the up arrow, I will go to the previous command that I typed in. Right now, the previous command that I typed in was man ls, right? So if I press the up arrow once, there's man ls. If I press it again, I go back to the previous command, so that's man calsay, right? If I press it again, I should go to history, I think. No, I should go to ls unsorted, is that right? No, history, okay. And then man calsay again, right? So I'm just working through the history now. Man ls, less sorted, ls, right? If you press the down button, it'll go forward through the history. You can access recent commands in the history by typing in the up arrow and the down arrow. Very useful when if you're working a lot on the command line. Another useful feature of the bash shell is something called tab completion. So when you're typing in a command and you press tab after typing in part of the command, bash will try to complete the command for you. Right? So for example, I start typing in cow, right? And now I press the tab key. I press it once, nothing happens. You press it twice, bash will tell you all of the commands that start with COW. Right? So it says there's something called calsay, there's something called calthink. If I then press S and then type tab, it'll automatically complete the calsay. Right? So that's called tab completion. Now, that's for the first thing you type on a line. Right? Now remember, some programs like ls, right? You can pass in an argument, right? So if I type in ls and then I start typing in I start typing in a word, right? So suppose I want to list the contents of output, right? If I type in O and then press tab, right? The shell will automatically complete the rest of the word, right? Because there's only one thing called output, right? There's only one word that starts with O, right? If I type ls and then F and press tab, right? It doesn't do anything, but if I type it again, right? It'll list all the contents that start with it, all the files that start with F. Right? So if I now type U and then tab, it'll automatically complete the full date. Right. So this is also very useful when you're working on the command line. Man page sections. So your man pages, there's a lot of them, right? So there's for many commands, there's a man page for that command. Now, if you're writing your own programs, it's not common to make a man page for your own programs. You could, but it's not very common. Now the problem is there's lots of commands with the exact same name. So the man pages are divided into sections, right? So you can see here there's 8 different sections. And if you have 2 commands with the same name, they will appear in different sections. Now the problem is you need to remember which section the command lives in. So let's take a look at an example. So wildcards, which I'll show you in a second, they form what are called globbing patterns, right? So let me just type man glob to show you what I meant by the previous slide. So if I type in man glob, right, you end up here, right? So up here you see this is the man page for glob, and then that number 3 means you're in section 3 of the man pages, right? And if you read what's going on with glob, right, it says there's this thing called glob. This is what it does, right? And then you got some gobbledygook here. So this is all C documentation. So it turns out this thing called glob is actually a function in C, right? If you want to find out what the wildcard globbing patterns are, right, this tells you that you have to look in section 7 of the man pages. So if I type in man 7 glob, now I have globbing path names, right? So that's what I mean by the man pages have different sections. If you type in man and you get something that you're not expecting, right? Man some command and you get the man page for something that you're not expecting. Just go through the man page and look for the other, right? So at the bottom you'll see also, right? So you see if you're looking for the C documentation for glob, you can type in man 3 glob. What does globbing do? So globbing lets you do pattern matching with file names, right? So the shell provides special character what are called wildcards. And this lets you create patterns that you can use to match file names. So the wildcard star matches any number of characters. So let's take a look at an example of that. So I list the contents of my directory. Notice I have lots of files that begin with the letter F, right? If I want to list all the files that begin with F, I can do lsf star, right? So star matches anything, right? So lsf, right? So list all the files that start with F and followed by anything, right? So that lists all the files that start with F, right? Notice I've got a bunch of things that end in .txt, right? So if I want to find those files, I can write ls star.txt, right? So match anything followed by .txt, right? And now you get all the files that end in .txt. The question mark, now star matches any sequence of characters, right? 0 or more of any character. The question mark matches any single character. So again, ls. All right, so suppose I want to find, is there a good example here? Matches, all right, so I want to find, I've got 3 directories here, dir1, dir2, dir3, right? I want to match anything that, I want to match any directory or file that ends in, let's say, 2, right? So I've got a dir2. Do I have anything else that ends in 2? Yeah, I've got a temp2 over here, right? Sorry, that matches any single character. Sorry, matches any single character. Right, never mind. No, that's fine. Sorry, I want to find any file that starts with dir and ends in a number. Right, so I can do ls dir question mark. Right, so this will find all files that start with dir and then have 1 extra character. Right, so there you go. Right, it lists the directories dir1, dir2, and dir3. Right, here I've got file 2, 3, and files.txt, so I can do ls file question mark .txt. Right, so this lists all the files that begin with file, have 1 other character, and then end in .txt. Right? So there you see it's file2, file3, and files.txt. Right? If you want, if you use square brackets, you can match any one character that's in the square brackets. So if I want to list file2, file3, but not files, I want to list file2, file3, but not files, I can do ls file23.txt. Right? And that will list file2, file3, but it won't list files, right? Because it will only match the stuff inside the square brackets. What else is here? If you want to, you can negate the characters that are, the characters that are in this set, right? So I put the exclamation mark here, right? It'll match anything that starts with file, not followed by a 2 or a 3, right? So now I only get files. And then finally, there's entire classes of characters that you can match or unmatch. Right, so I'll give you an example of that in a second, I think. Yeah, in a second. So here's a bunch of examples, right? So if you star, that matches all your file names, right? A star matches any file that begins with A followed by anything, right? Star.txt, all files starting that end in .txt, right? A star.txt, all files that begin with A end in .txt. Right? Question mark, question mark, question mark, right? That's how you match a 3-character file name, right? So if you're looking for a file that has exactly n characters in it, you can use n question marks. X question mark Z is any file that begins with X, ends in Z, has exactly 3 characters in its name. We looked at that already. Now, when you use the square brackets, you're allowed to specify ranges of characters, right? So for example, X, square bracket, A through Z means match any file name that starts with X, ends in Z, and the middle character is A through Z. So if you have a continuous sequence of characters that you want to match, you can use starting character dash ending character. Right? You can match the numbers with 0 through 9. Right? And this example down here, that matches any PDF file that's made up of 2 digits. Okay, now sometimes you are interested in matching specific classes of characters, right? So I know that my file name begins with a letter, right? A letter, just a letter, right? So alphabetic characters, right? So instead of writing A through Z, you can write this colon alpha colon, right? So ls colon alpha colon star. Right, so this will match all file names that begin with a letter. So alpha, did I do that? Oh, sorry. Is that right? Sorry, double square bracket. That's the problem. There we go. So that gives you back. Where do we? Here we go. So that lists all of the files that start with a letter. Now, notice when you do this, something interesting happens. Okay, so let me back up a bit. So if you list, if you ask ls to list a file and that file happens to be a directory, right? So dir1, oh, there's nothing there. Bin, there we go. So if it happens to be a directory, right, it will list the contents of the directory, right? So it won't print the file name. It won't print the directory name. If you just want the directory name, you have to use -d. So when I do that, right, this will match everything that starts with a letter, right? So it's going to match A, CISC 220, dir1, dir2, dir3, for example, right? What this will do, when it comes to listing dir1, it will list the contents of dir1. So you can see that it lists out all the files, And then for every directory that also matches the pattern, right? It prints the name of the directory and all the files that are in the directory. Right. So CISC 220 also matches that pattern. It happens to be a directory. It prints out everything. If you don't want to see the contents of the directory, and often you don't, use the -d flag, right? And now it just prints out the directory name and it doesn't print out the contents. Digits, you can use :digit. Lowercase letters, you can use :lower, and uppercase letters, you can use :upper. Okay. So these are also, you can also use this syntax if you like. Now remember, if you use these, it has to be inside the double brackets. And here's an example of using the wildcard class wildcard classes. Right. So double bracket upper, that matches all files that start with A through Z. Not, so you can use the negation operator. Right. Not upper is the same thing as lower. It's almost the same as lower. It's not exactly the same thing. Right. It's all files not starting with A through Z. Right. So anything that starts with a lowercase letter or a number or symbol will match this one. Right, and then any two X followed by a digit is what that matches. Oh, that's it. All right. That was a little quicker than I was expecting. I should make a note of that. I'm going to do that right now. Sorry. So I just need this for future reference. So that's all I'm planning on covering for today. Anybody have any questions? If you've got, if you're on Windows, so if you're on Mac, you should be, you should spend a few minutes playing around with the commands and seeing if you can get them to work and if they do what you expect them to. If you're on Windows and you have not installed or do not have access to some sort of Linux installation, you should probably get on that because you really need to do this sort of thing. You have to, this has to become, you have to try typing in commands repeatedly before this becomes natural. So you really do need to get some sort of, you need to find access to some sort of Linux installation, right? Either install the Windows subsystem for Linux or start remotely logging into CASLab. On Mac, no, you don't need to install anything right now. When we start C programming, you'll have to install the Xcode command line tools. Yeah, and you can use Replit if you want to try that as well, right? So for those of you who haven't seen Replit, it's pretty cool. Here you go. Do you actually have to log in now? Are there not free REPLs anymore? Anyway, hi, do you always have to log into this thing? Can I try this? Does this work? No, I have to create, I don't want to log in. It is free, yeah, but you have to, does it require a username now? Yeah, I think it always requires a username. I don't think it always used to. Basically, this gives you a virtual Linux console or other things. You can actually do a whole bunch of things on here. So it's actually pretty cool. So there, you could do it this way as well. Right, yeah, you can do Python. You can do almost any programming language, I think, in it. So it's kind of neat. Awkward, though, that you have to log in. I think you can embed these in web pages, too. But anyway, it's kind of neat. So that would be another way to do this if you don't want to go through the trouble of installing something on your computer. Right. All right. Any other questions for today? All right. So I would encourage, again, I would encourage you to start playing around on the command line because this is like any other skill. The only way to learn it is to actually do it. Yeah, you can SSH to CASLab. So if you have SSH installed, so that means you need PuTTY installed, right? So if you have PuTTY installed, PuTTY or another SSH client. If you're on Mac, you just type SSH into a terminal. So to SSH into a CASLab terminal, right? All the information for CASLab is here. If you go to the FAQ, sorry, how to. How to SSH to CastLab. Right. So you want to use a terminal, terminus putty, right? Let's do this one for the Mac, for the Windows people. So download putty, run putty, and you want to log into, for example, that. Is there a point to using Replit on Mac? No. On Mac, just go ahead and just use your native Mac OS, right? The only thing on Mac is if you haven't used a terminal in Mac, figure out how to open up a terminal. I forget. I think it's Command. I can't remember what it is on Mac. Command space or Command I opens up Finder. Once you have Finder, just type in terminal, and then you'll find you'll get a little link to how to open up a terminal. Anything else? Can we use? Yeah, is Kali Linux is good? Sure. Is the Looking Glass thing or the Looking Glass thing on the top right? Yeah, that's right. I don't normally use Mac. I have one. I don't normally use it. The only reason I have a Mac is so that I can make sure that software I've set up for students also works on Mac. Command space. Yes, there you go. Thank you. Okay. All right, it's lunchtime. I got to go. Thanks, everybody. I'll post the recording of the lecture later this afternoon.